I want to start with asking you, how many of you came by train today? Did, a lot of people. And how many of you had experienced any delays with the train? Also some people. Nice. That's what I was hoping for. Because I know a lot of Dutch people like to bash on trains, me included. So I would like to try to use Kotlin today in a data analysis package to see what kind of interesting stuff we can actually find about the delays of trains in the Netherlands. So I'm going to do some live coding. So I hope everything goes well. If not, well, yeah, bear with me. Okay, so to start off, I'm going to demo this in Kotlin Notebooks. This is a tool my team works on. I actually work in the Dataframe team at JetBrains. And well, I'm going to try to see what interesting stuff we can find. So I found some data considering or consisting of all delays of trains. And I found this on rijdendetreinen.nl, which is an app, but it also offers some nice downloads in CSV. So I found some train disruptions from the page. There's some downloads to the bottom. Yeah. So and to explore these in a notebook, all you have to do is just open the notebook, which I already did. Download the file, which I already did, and we can just drag and drop it inside. And there, we already have a working table. We can also find some interesting stuff about the table. Like you can see that some types are inferred automatically, which is nice. But there are some issues with the types, and we can see that from the website, because, for instance, the RDT lines ID is supposed to be a lines separated by comma. Well, that's not done correctly, because they're inferred as a double, because it's something with numbers and that it can happen. So what we can do is we can give our data frame a little hand and say that the column of RDT is supposed to be a string. So I can say, wait, let me see if it works. Because the read CSV function has all sorts of helpful additions. So we can say call types is map of, and then the RDT lines ID is supposed to be string. Now find the right type. You know what? I'm going to switch to my filled-in one. There. That's easier. Okay, let's start again. We have the notebook. And there, call type.string, that's it, of course. Let's see if it wants to run. Please. Yes. It always takes a bit longer the first time. And now we can see, if we print the schema of this table, that the type is correctly a string. Now, the fun thing about these data frames inside a notebook is that for each column in the table, a type-safe accessor is generated under the hood. So, for instance, if we have our table here, and here we can see for each column that's created, like RDT lines ID, or another one, RDT station codes, it provides an accessor on the fly, which you can use to type safely access your data. So like a column string. And if you want to see how that actually works in a notebook and how this is possible with Kotlin, we can create a tiny data frame like this one. Just a data frame, 2 columns, 1 and 2 inside. And we track what happens under the hood. And under the hood, you can see there's a lot of fancy stuff generated. Like there's an extension function here with letter A, and it provides a data column int. And in the next cell, this code is executable. So we can actually access dataframe.a, even though we just specified it as a string on top here. So that's cool. We have type safe, step-by-step data. So let's get back to our train data. And one of the things I always like to do to make it more like easier to work with is to what we name it to camel case for Kotlin. In this case, for the data, we can remove some Dutch columns because there are already the English ones. Remove some NS columns because they have different ones. Drop some columns where something is null, and helper columns. Like basic data improvements. So I was gonna type everything, but my cheat sheet doesn't work. So Dataframe offers a lot of extension functions on the Dataframe in which you can do all sorts of nice stuff. So one of the things you can do is remove. And since you can access all columns type safe, you won't get any runtime errors because you know the column NS lines is going to be right here. And in this case, we want to remove the NS lines columns and all columns that end in NL and the cause EN because there's a better one apparently. And then for the duration column, we're going to remove all the rows that are null. And we want to add some helper columns, which you can do like add duration from whatever and add date from. And rename some stuff. So now we have a very nice table. Almost correct. The only thing I want to do, because we want to find some interesting stuff, is split some columns up, because we have some columns that are split that have commas in them, and there should be like a list, which is easier to work with. So for that, we can use the split function, and we can split all columns like lines ID, station names in place. And nice, they are a list now. And we can also see from the schema that this now works. Oh, actually, I forgot in the beginning to tell you what I was going to find with the data. So let's go into that. So one of the things I would like to find about this CSV from 2023 is to find the longest delay, like which was the worst place to be at the time. What actually causes these types of delays? What are the cause groups and well, why are trains delayed? Which track or station had the most delays? And finally, you can already see it. Do I get to complain about Dutch trains in a live demo because I came by car? So the longest delays are actually very easy to find because these tables inside notebooks are completely interactive. So to find the longest duration, I literally just have to go to the duration column and sort them. And we can see the longest duration was 28 days. That's a long duration. And it was actually because of repair works, of course. So if you were in the line Leeuwarden Stavoorde, you were in bad luck. You might see that all these delays have a group, which is something like generic, and then an actual cause. So I was very interested in these types of groups and what they entail. So to find these things together, we can actually use the group by function. So I want to group by like the cause group, and then I want to collect the actual causes and then count the values in between and sort, of course, because the one with the most count should be on top. So the thing that happens the most is infrastructure, and we can actually go into the data frame in the data frame, to see that the signaling and point failure happened the most in 2023. So yeah. And for instance, for staff, we can see that people went on strike a lot, as they do. Accidents, of course, weather, like lightning strikes. Apparently, that's what causes delays. Weather circumstances, very vague. So yeah, it's really nice. So now to find out which line had the most delays, and for this we, since the lines column is actually a off-type list, we need to spread out the list over the rows, which we can do with the explode function. So if we first explode the lines, they get spread out. We group by. We can see like this, like the most delayed track was from Amsterdam, of course, to Schiphol Airport. Anyone take this train, this line? Yeah, you did. Nice. So yeah, that's the one that had the most delays. And we can do the same thing by station. So maybe Amsterdam station is the worst, maybe not. We'll find out. So we explode the station names with the delays. And we can actually see Rotterdam is it worse. So yeah, it could be, yeah. But yeah, just the number of delays doesn't tell the whole picture because some delays are longer than others. So for those, we can use the describe function on the column to get some more information about the distribution of the delays. So for Amsterdam Centraal, we can see that let's see, the max delay was 5 days, probably due to some repairs or something. And the median, so that gives like a good picture of the middle delay is about an hour. So yeah, it's not a nice station to be at. But yeah, yeah, like I say here, I don't know about you, but this table is not very nice to look at like this. We want the visualization. And for that, we have the Kandy library, which my team also develops. And it has a nice integration with Dataframe and the tables. So I can look at some examples of Kandy, because that's also always where I start when I want to make some nice plots. And they have the nice page with all these, I'm not sure if you can see, it's a bit tiny, of all different kinds of graphs I can make and then how I can make them. So for the duration, I think a box plot would be nice, because you can see like the median, the max, like the distribution of the delays. So to do that, I already have them like grouped by station. I only pick the top 10 because otherwise my graph would be very wide. And I can just use the extension function like dot plot to create the box plot with on the x-axis the station name, the y-axis the duration, and in this case I give them like nice colors. And usually if I print it like this, yeah, it's not very visible. So that's because a lot of the delays are very short. So, and some are really long. So to get a better view is to change the axis to make it like log 10. Ah, nice. And now we can see that maybe Zwolle has it even worse than Rotterdam, just because of the distribution. And to further explore the data like this, we can not just take the top 10 by count, but also by mean or by the count and the median. I think that's a nice one, actually. And since we're in a notebook, we can just go back and forth and update the code, like explore it really. So now Maastricht is actually very bad. So yeah, it's nice to get an overview, but we still haven't answered the most important question: do I get to complain about the trains? So for that, there's a little backstory, because I was a student and I had to go by train from Breda to Eindhoven from like 2015 to COVID, so 2020. And I did experience a lot of delays on that track. But like just me saying and complaining gives you no proof. So I actually created a very large database, an SQLite database, containing all the delays from 2011 till now, also from rijdentreinen.nl. And we can import this database in Dataframe. Just first having the dependency, and then connecting to that file. And we can just read it. And it will automatically like invert types, names, columns, and we have the entire database. Almost 50,000 rows, you can see. Very small. And this has all the delays in the Netherlands. So it's a lot. Now, like 50,000 is okay-ish. It's like Dataframe runs on the JVM. It runs in memory because so it can generate the type safe accessors. And for exploration, it's great. But if you have like a table with millions of rows, it might be a bit large. So what you can actually do if you have a large database like this is to only load in a specific query. So in this case, I only want to, why are you not scrolling? Yeah. I only want to select the disruptions related to the weather. So in this, we can just call like an SQL command, select all columns from disruptions where the cause group is weather. And now we only have weather-related, yeah, here, cause group. Only weather-related disruptions, which is nice. And if you want to plot something about the weather, like for instance, see in which month the most weather-related events happened, we can group by month, and we count, and we make a nice we see now an count per month, and we can just plot it really easily. And we can see actually it's best to go in April and September because those are the least weather events. Not sure what's about the weather event in July. I thought like sunny, it's nice, but no. Like, I mean, October or November, I understand because the Dutch train company is allergic to leaves on the tracks. No, not sure why. So, but yeah, let's go back to the whole data sets because we want to find something out about my experience. So I just to work easier with the data and because Dataframe was in Kotlin and you can just put any class or object into it. I created a line class just to give a line. And I'll just I'll brush over this because it's lots. It's the same as in the previous notebook. So we renamed some stuff, we removed some columns, and we sort. Let's see if it works because this is a large data set. There we go. And we can see all the lines. Now, the train track I used to have was from Breda to Eindhoven, and it also stopped in Tilburg. So I'll count a disruption as related to me when it happened either between Breda and Tilburg or Tilburg and Eindhoven. And for that, I just create my new line class, turn off the wrapping. And then I filter the table where the Breda Tilburg exists in the lines column or Tilburg Eindhoven exists in the lines column. And this is all the delays from 2011 to 23. So that's about 1,200 results. Nice. A lot of delays. Let's see. Oh yeah, we can of course see how do you want to plot them over time again. So I'll need to reopen this page to see what kind of graph we like. Like an area graph might be nice, or like bars, because then I can like stack them on top and then see which group costs the most, and then see like why my trains were delayed. So yeah, maybe like stacked area, stacked bars, something like that. So for that, I first need to add like a helper column just to get only the month and the year. And I group by the calls group, month and year, and then give a count. So it looks something like this. So per month and year, I have per group a count of how many times it happened, which will be nice to plot. And now we just need to group by cost group again, and then we can plot it. One thing I found while plotting is like this, because now each group has a different amount of rows, because not every date, not every month had an accident in that group. The graph would look all kind of wonky because there's like missing X data. So I added extra dates just with 0 accidents in that calls group. And now like the groups are of same size, which makes it easier to plot. So for instance, we can plot this as an area graph. And to see how to do that, I just choose one of these, which says like, oh, you have area, you give it an X, you give it a Y, maybe a color. Okay. And so I set the X to the month and year, Y to count, and the color to the group. And like if I don't stack it, just to start, we can see, there's a lot. And especially around this time, which explains my delays. And we can stack them on top of each other to get like a count. So yeah, you can see between like 2015 and 2020. Yeah, I think I have a reason to complain, right? And you can explore different types of plots right from the notebook. For instance, the stack bar chart also looks nice. You can also see like you can count how many times an accident happened. And yeah, around this time, the most things happened to rolling stock, which if I look back at the causes were mostly like broken trains and stuff. So there were a lot of broken trains on my track. So yeah, that's it. Now, you know, I have a reason to complain about trains. Let's answer the question whether you also will get to complain about trains this evening. So for that, I found from the same people who distributed the data, also rijden.nl. They have a GitHub where you can create a server, which I did, and it can give you live disruption data of the trains at any station. So that's nice. It has just a REST API, some calls, and yeah, we want to see that in the notebook, of course. So let's see if I can connect to my server. And apparently we can just get the system status by calling v2/status. So let's see if my server is still up. Otherwise the demo is going to be a bit shorter. Yes, it's up. And we can see that they are inverted strings because it's just raw JSON data. They also have like an open API schema for which for like all the addresses that are available and the types you will get back. And you can access this like online or download it. And in my case, I already downloaded it. And you can see like all the calls you can get and the types that will be returned from each call. So in this case, you will get a system states object, and the arrivals can be either unknown, down, recovering, or up. Okay. But like our data only has like strings now. So would it be nice like if they offer types that we can get the types in a data frame? Because like you have exhaustive whens, you can do like type safe accessing. And actually you can, because Dataframe has, you can import OpenAPI schemas, and this will import all the schema types and convert them to like Dataframe schemas. So in this case, we can just get the YAML file, and this will execute this under the hood, which like generates for each type the columns with interfaces and stuff. And this means we can now, from the thing we imported, like GoTrain, we can get a system status interface, and we can read the JSON, which then gets parsed to that object. So now, when we call it, we get the same data frame, but the types are actually status field, which is an enum that's generated under the hood. And we can see that it's an enum because like the compiler doesn't complain when I write this. So it knows that the arrivals can only be unknown, down, recovering, or up. Really nice. Now, in notebooks, because like after each cell execution, the accessors get inferred and generated, this is about as useful as they get, like the calculating of enums. But Dataframe is also, you can just use Dataframe in any project. So just in a normal Kotlin file. And then it's very handy to have like these generated accessors. So if I go to just a normal Kotlin file, and at the top, I write this, like import data schema from the YAML. And I run it once, I already ran it. Then the the same things will be generated under the hood. So in this case, we can actually view it. This is the system status interface that's generated. And the status field is actually, as you can see, an enum with only like 4 options. So that's a way to type safely access an API and immediately read them as a data frame. So I took this to a like a next level to write a function. I won't go into it in much depth, which can, for any station code, call a server and then retrieve the data safely and make it so that we can work with it later. And just to show that the things are actually generated, like for instance here, destination planned is some auto-generated code, which already knows that the type is going to be string. So, and the fun thing is, if you have your notebook in a project or next to a project, like I do, you can enable it as the sources, like as the just like if you have a library, and you can use it using this setting, like select module dependency. So I have selected the main module as a dependency to my notebook, which now means that I can call the function I just wrote in the normal Kotlin files from the notebook. So for instance, I can call get departures for station from Breda, which has the name BD. And we can see that a lot of trains are not cancelled. Surprise. And the departure times are like almost live, like 1915. That is almost. We can visualize them again. And let me open the site again. There we go. Nope, I need to close it first. Then open it anew. On the side, please. Yes. And one of the things I liked when I scrolled through the Kandy website of examples was the tiles function, because like, can you imagine like different tracks on the x-axis and then like a block for each train that's departing at a certain time? So that's what I was going to build, and I've already built it, of course. I'm not going to do that live. It's too much work. But yeah, that's the plot I made. So I just called my function from the main file. And then for the, like I add tiles for the actual train departure. So on the x-axis, I have the platform. On the y-axis, I have the departure time with added delay, so you can actually see the train leaving then. And I have a, oh yeah, we can just show it actually. So this is for station Breda. And nice, we can see per platform which train is leaving. Actually, it looks nice with Zwolle and actually my intercity Eindhoven, the one I used to take. Now, of course, just having the live trains is useful, but we can even add more. So one idea I had was to show the planned trains, like translucent with an alpha of 0.3. And like a line between the original planned date and then where it's actually going. So if it's changed platform, then you'll see a line between, or if it's delayed, you'll see a line. And that's a segment. We can see if we can see that. Ah, yes. The Sprinter to Nijmegen is delayed by, like, this is from 23 to 50. So yeah, there's some delay. We can even add some more stuff to the plot, like providing a cross through cancelled trains and just a line from the current time to see what we have. And we can actually see this one is cancelled. Nice. And this is actually live. So shall I show another station maybe in the neighborhood? Any stations you want to show, like Amsterdam Centraal, Utrecht? Utrecht? Okay, I'll first show Utrecht. I actually already know the code from this, but we can show it. Utrecht is nice because it's very wide. There's so many tracks. But we can only see like maybe this one to Amsterdam. Well, probably no one of you has to go from Utrecht to Amsterdam, so you're probably fine. And we can also show like Amsterdam. And there's more going on here. So if you have to go to Den Haag at 1941, you probably don't. Be careful, you have to go to another platform. So yeah, I think you can do anything. You can and to get like the code for the stations, there is also just a CSV from Rijden Treinen, and which I imported here. So that's how I figured out the names of the stations. So once at Amsterdam Rai, maybe let's see if we can find it. I can also filter. Rai. Maybe that's just a metro station. So that won't work. I'm not sure. But yeah, you can do anything. So that's about what I wanted to show. The power you have with the notebooks, what you can do with it, even if it's just to bash on Dutch trains. So thank you for listening. You can check out the project and run it for yourself. It's all available. And yeah, as a bonus, I just have here like a live plot of which one is this? Amsterdam, which updates live every 30 seconds or so. So you have the nice view and the same QR code if you want to see the project. So thank you for listening. Okay. Shall we continue?
Thank you, Johan. We have time for 2 questions, quick questions. Yeah. Anybody? No? Okay, that's good. Everybody.
Yeah, there's a question.
The mass. Oh, there's one question. Sorry. Testing. Okay, this is working now.
Microphone. Yeah, thank you very much for the very interesting presentation. I just have a question about possibility to export this analysis into some formats. Is it possible to export it?
Actually, yes,
else?
because these notebooks are based on the Jupyter kernel. You can these are just the same files as you have with normal like Python Jupyter files. So if you you can actually put this on GitHub, for instance, and then the plots and the data frames will be visible. It will be rendered there. Plus, you can also share these notebooks to like Jupyter Web or Datalore, and they will also just work. So it's not just limited to the IDE, but like I like the Kotlin experience in the IDE because the highlighting and stuff like that. But yeah, they're completely exportable.
Thank you.
Any other questions? Oh, I have one. Sorry, there is another one.
So do NS make this information openly available? Or
I think they said it on the GitHub from Rijden Treinen. They actually sourced it from another API.
nice. Which then gets it from another API?
Yeah,
another
probably
one.
like this, but this is from like a they just linked to the NS. But I think they got it from an like a TCP API somewhere, like just how was it called again? Socks. So it's easier to get at mass JSON. That's why I picked this one. So yeah.
Okay, so if you guys have any other questions, you'll stick around. By the end of the day, we can get with him and ask more questions.
Yeah, and there's also contact details in the QR code. So if you can, they're on GitHub if you want to talk to me afterwards.
Yeah. So guys, please give another round of applause to Jolan.
Thank you. Thank you.